Well, hello there. This is Central Coast Astronomical Society, and I am so excited. We are going to have a stargazing session tonight. How are you guys feeling? Woohoo! It's been a while since we've been here, and I am so excited to be able to share this with you tonight. My name is Aurora. I'm with the Central Coast Astronomical Society, and I have some special guests that are going to join me tonight. And one of the things I'd like your help with right away is, can you let us know where you are right now on planet Earth? So astronomically speaking, we could mention a few things that are in your area. That would be great. And so you can just stick that in the chat right now. If you're watching this as a recording, go ahead and let us know as well. So we would absolutely love to be able to connect with you and kind of know where you are. So yay! Hello everyone. So before we get started, we have a couple of little quick things to help you get the most out of tonight's presentation. So we are going to be doing a tour of the night sky. We have two specific constellations we're going to be covering. There is a handout that goes with our presentation tonight. It looks like this. You can download it. It is only one page. I know in the past I've written like 12 pagers, not just me, but the other two guests on that are coming on as well. And so we're decided to kind of tighten it up a little bit. And so these are the objects that we're going to be going through tonight. On the back, I went through and actually rewrote this for tonight's presentation based on all the questions that we've been getting for the past 2 years. So during our virtual stargazing sessions. And so if you've been wondering, oh, I really want a telescope, this is really cool, I really want binoculars. If you have equipment recommendation questions, please find that on the back. On the front, this is what we're going to be covering. One of the first things it says is make sure you download your sky map. So if you don't have it right now, that's fine. You can download it after our session tonight. And I actually put mine on a much larger piece. It does fit on an 8.5 by 11. These are free from skymaps. I always forget this. Skymaps.com, C-O-M. And you'll want to print it for your hemisphere. So north of the equator, northern hemisphere, south of the equator, southern hemisphere. The way this works is this thing goes above your head and it's projecting the night sky onto a piece of paper, which you're going to be seeing. The way I like to use these things, before I mention, forget to mention, on the back of it is also what's great to look at.
Aurora, we lost your audio. Okay, we're good.
All right.
You're back.
So I'm back. Thank you. That may happen a little bit tonight. My computer is having kittens right now. So how I like to use this is I'll get a pencil and a highlighter, and then I will circle or somehow star indicate things that we're looking at, kind of where they are. That's how I like to use these. So those two resources are available free for you, and we are going to get started. Let me introduce our first. Let me introduce Brian and then I'll introduce Kent. If you're brand new, welcome. We are the Central Coast Astronomical Society, and we are going to give you a tour of the night sky, and we're going to be looking at two specific constellations. By the end of tonight, our goal is so you can go outside, look up, and know where to look and what you're looking at. We're going to focus, most of the objects we're going to look at are naked eye, so really, really dark, or binoculars. So just a simple old pair of binoculars. These were like $30. Just any old pair that you've got that's collecting dust on a shelf will probably work just fine. And so you'll be able to go outside tonight. So we're really, really excited to share that with you. Okay, so first we're going to bring up Brian. Brian, are you there? Let's see if I can find you.
Hello.
Hello, there you are. So Brian normally would be outside or inside working a telescope. Is that right, Brian?
Yes, I would, except for those clouds that are not cooperating this evening.
Uh-oh. Sorry, I lost you. There you go. Yes, so he got clouded out tonight, but that's okay because he actually has some images to share as well. Is that right?
Yes, I do.
Okay, awesome.
Definitely. Yes, many different actual members of our astronomy club have submitted some images for our different objects, so I'll share those as the need arises.
Awesome. Okay, great. Well, thank you. All right, so we are going to go ahead and get started. And again, if my audio cuts out, Brian and Kent will let me know, and just know I'll be right back. So, all right, well, let's go ahead and get started. If you guys can drop in the chat, let me know where on the planet you are connecting from. That would be great, so we can give a few extra pointers to your area. That would be fantastic. And if you haven't already, like this video and subscribe. We totally encourage you to do that so you can follow us when we do more stargazing. We've been doing these since, is it March? Is that right?
March 2020.
March 2020. Speaking of which, why don't we bring on our amateur astronomer that's going to take us through the night sky. His name is Kent. Gosh, Kent, you've been with the Astronomy Club for a long time.
For a long time, yeah. I can't even, probably about 1996 or 7. Yeah, probably 96. A long time.
A long time. So I have an image here. You won't be able to see Kent, but because I'm going to be sharing my screen with you, you're going to be looking at this program called Stellarium. You can download it for free. I will be operating that so you can see that. And in the meantime, I will also be sharing images. So here's an image of Kent. Now, Kent, what is that next to you?
Yeah, that's my old orange C8. And that image in the upper right is when I was in Western Australia in 1999. And you can just see the telescope off to the left of that little image there. Also, you can see how flat Western Australia is. That's in the wheat belt, wheat and sheep.
Nice. And then this is a little bit bigger telescope.
Yeah, that's later. I air freighted a 20-inch scope to Western Australia to go a bit deeper. And the one at the top left is a prototype structure that I air freighted from Los Angeles to Perth, Australia. The one in the middle is actually the one I'd normally use at our star party. And off to the upper right, you can see the case that protected the mirror when it was air freighted to Western Australia.
Awesome. Well, we're really, really glad that you are joining us tonight. And Brian, do you want to mention if people are watching us and then they have questions or like, hey, wait, what is that? Or what's going on? Or I just have this idea and I had this question. What do they do?
Yes, right. Yes, definitely, especially since we are putting this on YouTube. But one of the great ways to enjoy our shows is from watching on a smart TV. That way you get the biggest screen possible. So we have a phone number where you can text in questions anytime, and that is at the bottom of the screen for the moment, but Aurora will be removing it. But it is 805-242-6415. And don't try to call because no one's going to answer it. But text, and then I'm watching that. Or you can email questions@centralcoastastronomy.org, and I'm watching that as well. And this is live all the time. So even if you're watching this as a recording, feel free to fire off those questions and we'll do our best to answer. And of course, questions relating to astronomy would be best. All right. Thanks, Aurora. And we've lost your audio. You're back.
One other thing, I just want to give a quick shout out. Thank you all the astronomers that are in the chat, in addition to Brian, that are answering the questions. I know we have a number of Central Coast astronomers that jump on to, we're just on YouTube right now, that jump on and help answer those questions. So I just want to say thank you guys for helping out. Okay, let's go ahead and get started. Make sure you get that information because I'm going to make it disappear so we can focus on the night sky. Are you guys ready? Okay, so Kent, when is the best time to stargaze? Any ideas?
Right now, this time of year, you want to do it when the moon isn't up. And right now is a good time. We're, a waning crescent moon. And so, it's not in the way. This time of year it's cold, so you're not going to last very long outside before you start freezing to death. And it gets dark early, so 7 o'clock's a good time. You can actually go out and see things quite well at 7 o'clock.
Awesome. Okay, great. Well, we are going to get started with our presentation. So what's the first thing that happens when most people go outside? Well, wait, Kent, don't answer that. I'll tell you. it looks like this, right? And it's really hard. It's like, well, is this the star we're looking at, or is it that one, or is that a planet? Or it can be really difficult. So to help you with that, we're going to give you some pointers, and I'm also going to put on, I mean, wouldn't this be nice if you could just do this in the night sky and boom, it would be easy, right? But it's not going to be like that. So periodically, as Kent goes through how to find things, I will be pointing it out to you as well, and we're going to go over and over it. So the first thing we're going to be looking at tonight is you're going to go outside and look west, and then you're going to look above the horizon, and I want you to tell me right now if you can see Cassiopeia. If I make it a little bit bigger, Cassiopeia looks like a 3 or a W, looks like an E sometimes. It's the crown. And you'll see 5 stars here. Do you see that? Okay, and if I connect the dots, okay, you can see it here. So this is what we're going to be focusing on first. And so let's make sure you can find it. So that's the constellation of choice. So you and I are going to be walking around outside. Okay, most people can identify Orion. That's great. That's going to be more in the east. So turn around if you see Orion. Okay, and now you tell me when you see Cassiopeia. See if I can get it on. Okay. Do you see it? Can you point to it right now? All right. Ready? 3, 2, 1. I know sometimes it's a little difficult on a computer program, so we're just going to do our best here. All right. So we are going to focus in this area of the night sky as well as Andromeda tonight. So this is where we're going to be looking. So again, go west, look up a bit, and we are looking for Cassiopeia. So Kent, you want to get started?
Yeah, let's do that.
Okay.
First thing, Cassiopeia itself is an ancient Greek constellation. Cassiopeia was the queen of Ethiopia. She bragged about how beautiful her daughter Andromeda was, and the gods sent a sea monster to punish Ethiopia. And so that's part of the mythology. They had to chain their daughter to a rock and sacrifice her to a sea monster. Luckily, Perseus came in and saved her. So it's all part of that old mythology. But anyhow, that's just a really quick overview.
All right.
And right now, Cassiopeia is kind of upside down. It's going down in the west. Constellations move from the east to the west. And so it's, above the horizon right now, but it'll be dropping down. So as you get later and later in the evening, it's going to get lower and lower in the sky. One interesting thing about Cassiopeia, you've got like the first 5 Greek letters, alpha, beta, gamma, delta, epsilon, and it turns out that Cassiopeia is beta, alpha, gamma, delta, epsilon. So it's got that little flip of the 2 brighter ones there. And so just figured I'd bring that up because we talk about, the various stars by their Greek letters.
Mm-hmm. Okay, great. So what's the first object that we want to take a look at?
Okay, we want to go for what's called the Owl Cluster, NGC 457. It doesn't have a Messier number, but it does have an NGC number.
Okay. And so what's the best way for people to find that?
Okay, start with the N star in Cassiopeia. That's called Epsilon.
Okay.
And then see how it's got a straight line there to essentially delta. If you kind of just continue it on a little bit and then go up a little bit, there's a naked eye star called Phi Cassiopeia.
Uh-huh.
And Phi is actually a 5th magnitude star, so if you have good dark skies, you should be able to see it. And it's right next to the cluster. Whether it's a member or not is kind of a question, but it's right next to the Owl Cluster. In fact, that's a good picture of it. You've got the 2 bright eyes, this kind of stick figure type object. You've got a little body going down. You got wings going off to the left and right. It's really a good object in my 20-inch scope with a really low power eyepiece because you have a big field and kids can really pick up on it. They've got a good imagination for stick figure objects. And so, this is what they call the Owl Cluster.
Nice. And Brian,
And
you said that one of our members has an image of it?
Yes, indeed. David Majors submitted one for us. And so let me share that with you.
Kent, what do you think about this picture? Let's see if I can get it on there.
Oh, that's a nice one. The owl is upside down, but that's a real nice shot.
Mm-hmm.
And you can see Phi, also that other brighter star next to Phi there, it's to the lower right.
Mm-hmm.
Those two form a binocular double. So if you look up there with binoculars, you should see Phi, actually I call it Phi 1 and Phi 2. They've got a separation about 134 arc seconds apart. And the dimmer one is magnitude 7, where the brighter one's magnitude 5. So that's kind of a nice little, binocular double that you can pull in. But yeah, they aren't quite sure whether those are members of the cluster or not. That's still up in the air. And want me to read this? I've got specs
you've got
this,
some specs on this. Absolutely.
Go
ahead.
This is what they call an open cluster. It's got a visual magnitude of 6.4. It's roughly 20 arc minutes by 20 arc minutes, where a full moon is like 30 arc minutes across, to give you an idea of size. Contains more than 200 stars. It's about 7,900 light years away. William Herschel discovered it on August 18th, 1780. Let's see, what else do I have here? The nickname for it, the owl cluster, there's some other nicknames. It's also called the dragonfly cluster, also the ET cluster, and also Phi Cassiopeia cluster.
Mm-hmm.
But under good conditions, you can see more members of this cluster with a pair of like 750s or 1050 binoculars. But it really looks nice in a scope.
Oh, yeah. Oh, that's great. So this is something, if you have dark enough skies, you'll be able to see. So one more time, to find it, you're going to find Cassiopeia by looking west, looking up, tilting your head back. You're going to find the two stars here on the end. You'll see how there's a larger triangle with a smaller angle here, and then this is a much larger angle. So you're going to look for that triangle. And if I pull off these things, you can see what it actually looks like without the little sticks. So you're going to go here. So you're going to connect these two stars and go out and up just a little bit, and you'll find that bright star, and put some binoculars on it or a telescope, and you'll see your object. Good job.
Yeah, the nice thing is it's a naked eye star for Phi there.
Yeah, that does make it easy. Now we are going to look at a Messier object next. Is that right?
Yeah, M103, which is another open cluster.
Okay. Let's find it. How do we find... Here, I'll put the bits back in. Okay, so M103. Okay, hey, that looked like it was pretty close by. In fact, here's the owl cluster right here. But now...
it's not far from, Delta, that Delta star there.
Okay, so what are we looking at here? What is this?
This is kind of a neat open cluster because it's got three bright stars across the center, but you can see color in the central star there of those three. It's kind of got a reddish or orangish tint to it. Let me give you the specs on it.
Yeah.
It's magnitude 7.4, so it's not going to be a visual object unless you've got super good eyes. It's only about 6 arc minutes across, contains about 70 stars, and is about 7,200 light years away. It's roughly about 25 million years old for an age. And Pierre Méchain discovered this cluster in 1781. It's the last object in Messier's original list. His original list went to 103 objects. Mm-hmm. Modern observers added on a few that he had written about in other journals, or I think one of them, a star chart of his, actually had it scribbled on on the edge or something like that. So over time, they've added a few more, and we're up to like 110 Messier objects on for a normal or a modern list. It's located about 1 degree northeast of Delta Cassieopeia, and that's right there. Let's see. Oh, yeah, it's got that red star, makes a nice contrast. It's also visible in 750 binoculars.
Oh, nice.
And so that's M103.
Excellent.
And that's nice. The two are close to each other. So
yeah,
you got the owl up there, and then you've got M103 just over there on the other side of Delta.
That's wonderful. Okay, great. All right, so moving on. What's the next one you want to talk about tonight? Oh, and by the way, just so you know, or not you, Kent, but so everybody else knows, Kent is not looking at any star charts right now. So he's been observing for such a long time that he literally is just sitting on a phone, and it used to be a rotary phone, but he now has the push button dial kind, and he's sitting there talking to us. So he's remembering what the stuff looks like, and he's remembering a lot of detail. So if you have questions about things, please let us know so we can help answer those as we go along. All right, you guys ready for the next one? What's the next one, Kent?
Next one's interesting. It's NGC 281,
okay,
what we call the Pacman Nebula, and it's an emissions nebula.
Okay.
And in fact, if you kind of blow it up, you can see it kind of looks like the Pac-Man. It's got a little wedge taken out of it right there. It's kind of a neat little object. It's got a visual magnitude of 8.0, a size of 28 arc minutes by 21 arc minutes, is about 9,600 light years away. Edward E. Barnard discovered this nebula on November 16th, 1881, using a 5-inch refractor. You know, there weren't any filters back then, so he had really good eyes. I think it was from Nashville, Tennessee.
Oh, wow.
That he actually discovered this little emissions nebula. There's also an open cluster right in the center of it. They call that IC 1590. And right in the center was discovered by, and I'm going to butcher this guy's name, Guillaume Bigordan, sometime before 1891. It's located about 1 degree and 34 minutes east of Alpha Cassiopeia. And so a lot of times you can go to Alpha and then just slide east to find it. It responds well to an O3 filter.
Okay.
O3 filter and low power, so you have a wide field. There you go, yeah.
Yep. Okay, so Alpha, remember,
that's
is
the
this
Alpha
one.
star there.
Yeah. Mm-hmm. And so if we do it
And
without the
slide
lines,
over.
there you go. Okay, you're just going
In fact, if you have binoculars and a filter, you might be able to hold your binoculars on the area, and then, you know, it just takes some dexterity. Hold the binoculars one hand, close one eye, and then move the filter between your eye and one of the eyepieces on the binocular, and you might be able to blink it into existence.
Nice.
And so I've never tried that, but it's definitely possible.
Okay.
To do something like that.
Nice. And so...
And I just like the name. Pac-Man's kind of cool.
It is kind of cool. And it really does look like it. And somebody was asking about the picture here. This is not actually a Hubble picture. This was taken with a 127 millimeter refractor and a whole lot of filters.
It's amazing what they're doing with the CCD cameras.
Yeah, it truly is.
You know, it is. I mean, you know, they a lot of times they take a whole mess of shots of the same object, and then they look at it and throw out the ones that look fuzzy, and just stack the ones that are nice and crisp.
Yes. And
you're getting things that look like they came from the Hubble. It's really totally amazing what they've done with the CCD cameras.
Yep, absolutely. Now, this is the one I had... Oh, was this the one I had trouble with? Oh, no, it was the other one. So this is NGC 7789.
Oh, yeah, Carolyn's Rose.
Yes.
It's a rich open cluster. It's actually kind of between two stars in Cassiopeia, Rho and Sigma, but they're about 2 degrees. Rho and Sigma are about 2 degrees apart, and it's about 3 degrees from Beta Cassiopeia. So we have to go to Beta and then go about 3 degrees south-southwest to pull that in.
Okay, so let's see what it actually looks like here. There we go. Oh, I'm sorry. You can't actually see what I'm doing. I'm so sorry. Here I am trying to I was stuck on the thing.
We've been sitting on the Pacman for a while.
I'm sorry. I was.
No, that's
I
okay.
didn't realize
You got
it. So here we go. So let describe that again. So we have the Beta star.
Okay, that's Beta.
Yes.
Cassiopeia, and you just go southwest, and see it's between two relatively. There's one and the other, Rho and Sigma, and there's this fuzzy patch there, and it's really a beautiful open cluster. When you're there, it's really quite rich and condensed. It was found by Carolyn Herschel, the sister of William Herschel, who found so many deep sky objects. She had a little sweeper scope, and she swept that up. She had the very first visual observation of that open cluster, which is called NGC 778. I'll read the specs on it. It's got a visual magnitude of 7.8,
Okay.
a size of about 25 by 25 arc minutes, contains over 580 stars. It has an age. It's an oldie. It's 1.6 billion years old. So it's really out there. Carolyn Herschel discovered it on October 30th, 1783. It's visible in 750 binoculars, and it's really beautiful in larger scope, like a 8-inch scope.
Nice. Yeah, it's a really nice one to look at. So this one would be an open cluster. Is that correct?
Yeah, it's an open cluster. You can kind of see right through the center of it.
Yeah.
I don't know if we had anybody take a picture of it or not, but
I'm not sure. Brian would have those. The only one I pulled was the one from the observatory. This was
next one I have is for the bubble.
The bubble. Okay.
Next up.
Oh, okay.
Okay, great. So speaking of which, or actually, let's talk about M52 first.
Okay, yeah, M52 is a good one to talk about.
Yeah, let's find it.
So we'll have to go out.
Okay. There we go.
There we go. And we were talking about that during the rehearsal.
Yes.
How try and find a good way to see it. And paper charts have limitations where you can show the whole thing on a computer screen. A lot of times you just get pieces of it on a paper chart. But the kind of interesting thing is M52 is kind of like on a straight line from alpha to beta. Just keep on going a little bit over the distance, and it gets you in the area.
Yeah.
And you got to kind of blow it up to actually start seeing it as a cluster, but it's not a bad little cluster.
There you go.
As you can see there. And let me read the specs on it. It's got a visual magnitude of 6.9, which isn't bad. Size, it's about 16 arc minutes by 16 arc minutes. Contains over 130 stars. It's about 4,600 light years away. Charles Messier discovered this one on September 7th, 1774. And it's located about 6 degrees northwest of Beta Cassiopeia. And M52 can be seen in 750 binoculars, and it really looks nice in an 8-inch scope. It becomes a rich open cluster. So we've been really hitting the open clusters tonight.
Yes, we have. So just to kind of reiterate here, when we started, we were looking at Cassieopeia, the 5 stars here. Let's do it without the little things. So we got 1, 2, 3, 4, 5. And so this would be your beta, and this would be your alpha. And
we don't. We just got M52 picture there. We don't have the graphics up.
oh yeah, that's I'm so sorry. Thank you. Okay, here we
No,
go.
that's okay. There we
Thank
go.
you. Thank you. I have so many controls in this computer that it's good that you're telling me. If you can't see anything. Okay, so we have the 5 stars. We have 1, 2, 3, 4, 5. And the first
Like
thing
that.
yep. And the first one was
If you actually called out the Greek letters, it
Oh.
would be at the end. That one's actually beta.
Beta.
That's alpha,
alpha.
gamma, delta, and epsilon.
Perfect.
So those are the Greek letters for those. Those
Yes.
are the brighter stars in Cassiopeia.
Yes.
And so to go for M52, we want to go back over to alpha and beta and just continue on down about a roughly equal distance. And that's too far. You're circling a nebula.
I am. That's the wrong nebula.
There it is.
Yep.
Roughly, there's a little star there, and there's some fuzz around it.
There
it is.
Yep. Okay, great.
And so that gets M52, and it pops out better in binoculars than it does on the computer screen.
That's true too.
You've got to give that caveat out there. When you see how it's a little bit longer than the distance between alpha and beta there. If you extend a line, they're almost on a straight line, so that'll get you in the right area. And then you just kind of circle around with your binocs, and you should find a little fuzzy object there. Or if you've got a telescope, use your finder scope. Kind of look in that. Should be able, if you've got like an 8x50 finder scope, you should be able to see there's a little fuzzy blob there.
Nice.
Then you look through your eyepiece and you'll see something really cool.
That's awesome. Okay, so now when you were going through Cassiopeia, I could not believe how many cool things there are to look at. I mean, we've just done 5.
Oh, there are a lot more open clusters. We went for the brighter ones. There is a lot of stuff. In fact, I think the last time that we did a virtual star party, it was in Perseus. And one of the questions that someone asked was, what about the Heart and Soul nebulas? Well, it turns out the Heart and Soul nebulas, they're at like the lower end of Cassiopeia. They're actually in Cassiopeia. They aren't in Perseus. So that's why we weren't covering the Heart and Soul nebulas. And you can see them on your graphics there, those 2 reddish blobs off the end of, there they are. You circled them. And notice how the double cluster is right above them.
Oh, yes, it is. Look at that. Right there?
Got the double cluster right there, yeah. But there's like a boundary between the 2, and those happen to be in the territory of Cassiopeia. Just wanted to bring that up because I happened to see it there.
Good memory. Good memory.
And then another cool thing is that since we got M52 there, it's in line for our next object, which is just nearby, which is the Bubble Nebula. It's NGC 7635.
Okay, let me actually type in the box. NGC. So by doing it this way, I'm able to actually put braces around it so you can see. And that looks pretty nearby, doesn't it? Looks like we're extending this again.
Oh, we got a picture here. Somebody took a picture.
Oh, you
sorry,
have
that's
a picture.
right. Sorry, that when I share, that overrides your view. Apologies.
Oh, that's okay. So this is the Bubble Nebula. What is this, Kent?
Okay, the surrounding nebulosity is an emissions nebula.
Okay.
But there's a really hot star that's probably traveling through there, and it's either blowing its own, probably the radiation is so heavy from that super hot star that it's pushing away the material. And you can see it's not symmetrical. It's way off to one side, so I assume that's the direction that the star's traveling. And radiation is trying to push stuff out. It's probably encountered thicker parts of the gas cloud.
Yeah.
And so let's see what specs. It's called the Bubble Nebula. This is an emissions nebula with a visual magnitude of 10.0. The size of the general nebulosity around there is actually 15 arc seconds by 8 arc seconds with a distance of roughly 7,100 light years. William Herschel discovered the basic nebulosity there on November 3rd, 1787. And this nebulosity is only about 35 minutes southwest of M52. And it's important to remember that the bubble nebula is only one part of NGC 7635. And the very hot star is a ninth magnitude O type star. Those are the really hot ones. They've got a SAO 20575 name. There's some other names.
Wow.
But it takes a fair-sized telescope and an O3 filter to actually see part of the bubble itself.
Mm-hmm.
I remember when I was young out there at the old buried water tank, using an O3 filter with my 8-inch scope, I could actually travel along some of the edge of the bubble from the bright star. I could see a little bit of the curve of the bubble. I couldn't make a full circle, but I could see part of the curve there.
Oh,
In fact, if you're blowing up, see how close that M52 is?
Yeah. Yeah.
There's M52, and there's the bubble nebula, or actually, it's general nebulosity with the bubble in there. If you have a really big scope, it makes it easier to see.
Yeah.
And it is a really neat object. You know, if I tried my 8-inch now, since I'm a geezer, I probably would be. I could probably see the bright star, but I'm not sure I'd pull in any of the curve of the bubble there.
Oh, wow. That's amazing. We've got a lot of questions that are coming through. Astronomers are doing a good job answering them about what made the bubble, what is it, what kind of star. That's awesome.
The bubble itself is about 3 arc minutes in diameter, to give you an idea of size.
Okay.
So it's like 1/10 the diameter of our moon.
Wow.
So it's not really small,
No.
but it's not really large either.
Yeah. All
And
right.
it's just, you know, if you're going after M52, you might as well take a little detour over and see if you can, you know, at least see the nebulosity. An O3 filter or UHC filter should pull it out.
Okay.
But seeing the bubble itself, you might have to have good seeing or something like that to pull it in.
Here,
and there's another shot of it.
Yeah. Who submitted this one?
This one is from Philip Klein, another club member.
Oh, nice. He does beautiful work. Very nice. Look at all that.
Yeah, I mean, just to pull in the bubble ain't easy. I mean, most of the pictures, like that one, is a Hubble shot.
Oh, yeah.
But, you know, the one that looked really nice. But this, I mean, for, you know, what amateurs do is amazing.
Yes.
You know, that they can pull in stuff like they do. Also, the tracking is, I mean, tracking used to be a real nightmare. People would look through this little eyepiece and have to keep right on a star for hours in the cold, just holding it right there in the center of their little square or whatever. And they do like 4, 5, 6 hour exposures.
Yeah.
Just holding it there so that film could collect enough light. You know, CCDs are like 10 times more efficient. So, you know, you don't have to track. Plus, they've got really neat devices for tracking now. So I'm a dinosaur when it comes to stuff.
That's okay. What you have in your head is amazing, and that's what we love to be able to share with everyone. All right, so before we move on to our next how was that? Was that fun? Let's do a quick refresher. So I'm gonna, you're seeing me just for a second while I turn everything off. I want you to tell me right now, we're going outside for a walk. You tell me when you actually see Cassiopeia. Here, we're gonna go for a walk. Let's see, sometimes the computer program is not nearly as easy to use. Okay, so you tell me, where is Cassieopeia? We're looking kind of northwest-ish. Do you see it? Okay, yep, it's up in here. So you're going to take out your binoculars. The first thing we looked at was the owl. So we have, well, here we have beta, alpha. What was the third one, Kent?
Gamma,
Gamma,
delta, epsilon.
and epsilon. Okay, so you're going to take the smaller triangle and connect those two till you get to the owl, which should be this guy right here. Is that right, Kent?
Yep.
Yes.
If you keep blowing it up, it'll pop out.
There we go. There he is.
There it goes. You can see its little wings. It's got feet.
It's so cool. Okay, so here's Cassiopeia again. 1, 2, 3, 4, 5. And then we went back to Delta, and then we went over in this region. And do you remember what we saw here? We saw an open cluster.
Actually,
is that right? No. Did I have that wrong? M103?
No, I think you went a bit too far.
I did go too far. This is 103 because it has the color. You're right. Look at that.
If you can blow that up, it should pop out should have a little orangish or reddish star in the center.
Yes, it does.
So I think it's right there.
It's right there. So this was your owl, and notice how close it is here. The third thing we saw was the emission nebula, was the Pacman Nebula, and to get there, we went back over to this side. And here, let me put the little stick figures in. And you're actually going to go about this far. Is there a good way to find it other than just coming off the alpha star?
Not really. It's, one of those, doesn't have an easy thing to find it. Let's see, I had a...
Okay, no, that's fine.
Yeah, you can be about 1 minute and 3/4.
Okay.
Over from Alpha there.
Perfect.
Going east. So it's straight east. So if you can slide eastward.
Okay.
Or if you're very patient, it'll, over time, east becomes west.
You could
and
just
so
sit
it
there.
will, if you don't track, it'll drift over to you sooner or later.
Nice. Okay, and then the other two were down. Oh, no, wait. We have Carolyn's Rose and then M52. And so we connected alpha and beta to go.
Right. Beta is a good starting place for Carolyn's Rose, which is 7789 or NGC 7789.
Mm-hmm. Okay.
And I think it's about 3 degrees southwest of Beta.
Okay, and you'll find it between these two stars in here. And then we go...
And it's really obvious in binoculars when your field of binoculars should hold, I think 750s have a field about 7 degrees.
Oh, wow.
Something like I might be wrong, but I'm thinking that's what's rattling around in my head. And so, those two will fit in the field of view quite well, and then you'll notice there's a fuzzy patch between them.
Yeah, perfect. And then we'll slide back over to the beta star, and this is where we extend down, and we're going to see two objects down here. Let's see if I went too far. Nope, they're right here, aren't they?
Yep, you're circling them.
Okay, great. And so this is
you've
where
got M52 there, and you've got the Bubble Nebula.
Perfect. Wow, there's a lot in Cassieopeia, and I'm sure you're going to tell me there's even more, right?
Oh, there's some great double stars also. We didn't even touch those.
That's all right. All right. So how are you feeling out there? Whoops. Oh, hi, Brian. Sorry, wrong camera. So for those of you who are watching us, drop us a note in the chat. Let us know how we're doing and how you're feeling about the content so far. We are going to shift gears and go to the next constellation. So you ready? All right. So hit the throttle on your spaceship. We are going to go find Andromeda. And if someone's never found Andromeda before, where would the constellation, how would we do that, Kent?
Well, I would start with actually what they call an asterism, which is the Great Square.
Okay.
And so there's the Great Square made up of Pegasus, the flying horse, and Andromeda herself there. And the one corner star is the alpha star of Andromeda. So that's Alpha Andromeda.
Mm-hmm.
Then you kind of sling over to, what is it? It'd be going east, I think, or west. Yeah. You got Beta and Gamma. Those are the three bright stars there you go. There's Gamma, which is actually Gamma's a really nice double star. And there's Beta. Beta is a good stepping point to, and you can see the W from Cassieopeia just on the other side there. So it's not that far away. But the Great Andromeda Nebula, M31, it's kind of easy to find. You go to Beta, 1, 2 stars.
Wait.
It'll pop out in binoculars.
The Andromeda Nebula? Did you say nebula?
Yeah, they call it the Great Andromeda Nebula, or actually the older name is Great Andromeda Nebula, but it's really a galaxy, and so it's really the Great Andromeda Galaxy. It's a naked eye object. Out at Navajo Flats, I can look right up and see it as a fuzzy patch, just off of that one star there. And so, it's a big galaxy.
Yeah.
It's only about 2.5 million light years away, so it's quite near as far as big galaxies. It's actually probably a little bit larger than our Milky Way, but it's a little less massive than our Milky Way. Visual magnitude's 3.4. Some people with binoculars have been able to follow the length about 4 to 5 degrees. So if you're got a really good dark skies that's overhead, you can really follow the extent way out on either side. And so it's really a neat object that way. It's basic size that they give is about 3.5 by 3.5 by 1 degrees. And, also the first written records are from a Persian astronomer, Al-Sufi, who wrote about it in 964 AD. And so he had the first written record. I'm sure people saw that little fuzzy cloud up there and noticed it never moved. And so that's kind of a neat thing about it.
Yeah.
Also, it's part of our local group. There's a group of galaxies. It's the Milky Way and Andromeda are the two big members of the local group. Also, you've got M33, which is a face-on spiral, and then there's a bunch of little dwarf nebulas. And the Andromeda galaxy is inclined about 15 degrees from being edge-on. It also has a very bright star-like nucleus. In my 20-inch, you can actually see the dust lanes that are on M31. At star parties, it was fun to show people, tell them where to look to see the dust lanes in the 20-inch. So that was cool.
Nice. Now, when you look at this in binoculars, the picture I'm showing you now is not what you're going to see.
No. It's more like you just see like a glowing elliptical shape. You can tell it's elongated.
Kind of looks like something. Yeah, it looks like kind of between these two pictures. Like I can't do that, but it's it's got a green.
In binoculars, probably naked eye, it looks like the one, and then the brighter one's probably more like binocular.
Here, so we have this is what it'll look like. You can tell it's not a star because it's fuzzy, and it'll be kind of a green tinge to it. And then binoculars, it'll look like that. And depending on the size of the telescope, you can see a little bit more like that.
Yeah, it keeps going and going. And,
yep.
In my 20-inch, you can see the star-like nucleus. You can see the dust lanes.
Wow.
Also, there's two satellite galaxies.
Yes, let's talk about those.
M31 is the one that's kind of embedded in Andromeda. That's 110.
That's 110.
So right there, yeah.
M30, you mean M32?
Did I say, I said M31, didn't I? Yeah, it's M32.
Okay.
It's an elliptical dwarf galaxy. These littler galaxies, they call them dwarf galaxies. Kind of like the large and small Magellanic Clouds are dwarf galaxies to the Milky Way. And these two are dwarf galaxies for Andromeda. The specs on it, it's M32 has a visual magnitude of 8.1. Size is about 8.7 arc minutes by 6.5 arc minutes. And it's the same distance as Andromeda, about 2.5 million light years away. It only masses about 3 billion solar masses, so that's not very much. I think our Milky Way is pushing towards a trillion solar masses or something like that.
Wow.
In fact, I don't know if I wrote down I don't think I put down the solar masses for Andromeda, but I think it's on the order of 700 billion solar masses, something like that.
Okay.
But it can be seen in 750 binoculars, but it just looks kind of like a fuzzy star. You have to have a good night of seeing to say that's a star and this thing's fuzzy, so that's not a star.
Yeah, and again, it's going to be super small. Okay.
A guy by the name of Legenta discovered it on October 29th, 1749, and it lies about 22 arc minutes south of the core of M31. So if you've got something where you've got directions, you could look at the bright star-like core, just go straight down about 22 arc seconds, a little bit more than what, about 2/3 of the moon diameter, something like that. So it's close by.
Awesome.
And so that takes care of 32. I keep getting 32 and 31 mixed up.
Well, we know 31's the bigger one. And actually, Brian has a picture that he was going to share. Brian, do you want to share it? Well, Kent talks about 110.
Absolutely.
Let's see. Where are you? There you are.
So, yes, this one is from Patrick Rebstock, another club member.
Ooh.
Oh, that's nice.
That's a pretty one.
Yeah.
And you can see how the core's, when you look at it kind of hard, you can see the core's almost stellar there.
Yeah.
And that's hard to get in a photograph. But you can definitely see 32's fuzzy. And then you've got 110 out there, which is more elliptical. The dust lanes show up really well. That's a nice photo. Or image, I guess. It's probably CCD.
It's okay. We know what you mean. You can call it
Yeah,
a photo.
I don't have any details on how he captured this one, but yes, I'd say it's either a CMOS or CCD camera for sure.
Yeah.
Yeah, that's a nice one.
Nice. And do you want to tell us about 110?
Yeah, let's flip over to 110, or
Okay.
you want to keep this one?
Yeah, we
in
could
there?
keep this one up. It's a nice picture.
Yeah. Yeah, 110 is called a spheroidal dwarf galaxy because it's not round, it's actually a little bit elliptical there. It's again a companion to M31, kind of goes around it over billions of years. It has a visual magnitude of 8.1 and a size of 21.9 arc minutes by 11 arc minutes, and a distance of 2.57 million light years. So they have a little bit of difference, maybe a little bit further out than Andromeda. It masses 10 billion solar masses, so it's got a lot more mass than M32. I think M32 we had 3 billion solar masses. Charles Messier discovered M110 on August 10th, 1773, but didn't publish the discovery until 1801. It's located 38 arc minutes northwest of the core of M31, and under good conditions, M10 can be seen in 750 binoculars. One interesting thing on the history of M110 is that Carolyn Herschel found it independently, and it was listed as her discovery until this 1801 publication by Charles Messier popped up and said, "Oh, I saw it before you." So poor Carolyn Herschel, nowadays it's first published, first credit,
Yeah.
But they had the notes and stuff, and he really did see it before Carolyn Herschel. He just didn't let anyone know about it.
Oops.
And so that's the history behind it.
Okay.
One interesting thing is when you blow up 110, it actually has some dust clouds in it, believe it or not. You have to have more like a, super big, probably professional scope to actually pull out the dust clouds, or a good CCD camera in patience. But there's actually some little dust clouds in that elliptical or spheroidal dwarf galaxy.
Oh, that's cool. All right, well, let me pause you right there. I know you got 2 more to go. And so real quick, if you could point out Cassiopeia for me, everyone. Can you do that for me right now on the screen? Okay, so here's Cassiopeia. Okay, did you get it? Okay, now the larger triangle is the one that's pointing to this really bright star here in Andromeda, and it's the beta star. And if you'll notice,
beta.
yeah, and of course I needed the program in order to tell me that it was beta. I know you know that, Kent. So this one is pointing to this bright star, beta Andromeda. And then you'll notice it's got some stars that kind of lead you back to this triangle, and you'll count. So the beta stars 1, 2, 3, and right at the end of that third one is where you're going to find Andromeda Galaxy. So that's another way you can find it as well. Okay, so I had trouble with this next one.
I have trouble with it too. But
you
we
do?
found a way. we found a way using the great square to find it.
We did.
There you start with the alpha star. And this is a planetary nebula, so it's a small object. It's actually got a nickname. It's called the Blue Snowball. It's NGC 7662. It's a planetary nebula, and we discovered that it forms an equilateral triangle, roughly equilateral triangle, with 2 of the stars in the great square there. The first one's Alpha Andromeda, and I forget what the one in Pegasus is. I'd have to look it up.
Let's see, I've got Beta here, and I've got Alpha.
Okay, so Beta Persei. But yeah, you use those 2 and just extend them out like a equilateral triangle, and it gets you really close.
Yes.
To 66, or
should we see what it looks like?
662. And there's what it looks like. That's actually a nice shot. You got the central star, and you've got the. It's not blue in this photo, but a lot of people see it as blue. The specs on it is it's got a visual magnitude of 8.3, a size of 32 arc seconds by 28 arc seconds. It's roughly about 3,200 light years away. The central star has a magnitude of 13.2, so that's not going to be easy. William Herschel discovered this planetary nebula on October 6, 1784, and how we pointed out how to see it's probably the best way to find it. I've seen it through my finder scope on my 8-inch telescope, just blinking it with moving an O3 filter between my eye and the eyepiece of the finder scope, and it would blink. So that's kind of cool.
Yeah.
In my 8-inch scope at 62.5 power, it's a nice pale blue disc. Without it, I couldn't see the central star, but I could see the blue disc.
Now, you were talking about this curve of stars. So if you see...
those 3. So if you were, roughly looking out there with binoculars, you could see those 3 stars, just drop down from it, and boom, hit the area. Mainly what you do by that time is, take out your telescope.
Yeah.
And I usually do like a spiral pattern. I kind of pick a point where I think it is. When I look through my eyepiece, it isn't there. Then I start making a spiral around the center, kind of like a search pattern. To, once you find it, it'll be, a blue disc, and you're like, cool, got it. But that's, a way or technique that I use to, run down these guys.
Nice.
And so that's pretty much the story for that one.
That's great. You know, I'm just noticing here too. I'm not sure how easy it is to see it,
Oh,
but
we talked about this.
Yeah.
This is cool.
Go ahead.
Got a right angle triangle there, and if you go roughly halfway along the hypotenuse, which is the long side, it gets you right to that area too.
Yes.
By using the beta star in
Cassiopeia.
Cassiopeia, and that's
the
a beta
Pegasus.
Also. Pegasus. Yeah, you go like roughly halfway between, and it pretty well gets you there.
Yes.
So, that's another way of just getting into the right area, and then you have to kind of search it down.
Yes. Yeah, and this is a telescope object, just to be clear.
Oh, yeah, definitely not, binocular, it would be tough. You'd have to play with a filter, looking through. Some people actually have great big filters that they put over both, lenses in a pair of binoculars. But that's some heavy-duty money.
Yeah.
Doing something like that.
Yes.
But
yes.
There's some nice, Hubble-type images.
Nice. Now the last
one.
Oh,
they got it labeled incorrectly there.
What?
7635 is the Bubble Nebula. This is 76.
That was my fault.
2. Oh, was that your fault?
That was my fault. Here, I'll correct it right here.
I thought it was something from the.
Oh, I'm sorry. You're absolutely. Well, it kind of looks like a bubble. Here, I'll correct it. So it's 7662, and it's called
there
the
you
blue.
got it. Yeah.
Whoops, I'm sorry.
Blue Snowball.
There we go. Okay, so if you're taking screenshots, now you can do it. Okay, perfect. All right.
And we got
have
one more object left.
Yes. What are we looking at last?
The last one is a galaxy.
Okay.
It's an edge-on spiral galaxy called the Outer Limits Galaxy, and it's NGC 891.
That's not even remotely close to where we were.
Well, look at Andromeda there. You got Alpha, Beta, and Gamma.
And it's right off of Gamma.
So, it's off of Gamma, but also it's kind of in line with a little open cluster in Perseus that we've talked about before, which is M34. It's actually a really neat edge-on spiral. They've got this thing, the Outer Limits Galaxy, based off of the old black and white Outer Limits TV show, the original series. At the very end of the show, they'd run through the credits, and they would show as a background, along with the eerie music, pictures from like Palomar and other big observatories. And this was one of the galaxies that they had. And I remember as a kid, I'm going like, oh, it'd be so cool to know what that is and where it is and that sort of thing. But it's got a visual magnitude of 9.9, so it's a telescopic type object. It's got a size of 11.7 arc minutes by 1.6 arc minutes. It's about 31 million light years away. It masses about 150 billion solar masses, so it's a big one. Tilted only 6 degrees from edge on, so it's really close to edge on. William Herschel discovered it on October 6, 1784, which is actually the same date he discovered the blue planetary, or the blue Snowball, Nebula. 7662 was also discovered on that same night. So he had a good night that night.
Yes, he did.
And it's about 3.4 degrees east of Gamma, Andromeda. Remember how we're looking at Gamma? And also it's roughly between Gamma and the open cluster M34 in Perseus.
Is it this one here?
You can see how that's M34 there.
Okay.
And so if you draw a straight line from it to Gamma, you can see it's roughly between them. A little bit high, but it would give you a good starting point to move your scope around.
Nice. Now, is this something I can look at with my binoculars, or I got to drag out the telescope?
Your 100 millimeter binoculars would work. I think.
Oh, I think I'm going to try that when we're done. These guys here.
You might, those big guys would probably work, but your average, 750s, 1050s, probably not for, almost everybody.
Okay.
Best thing to do is if you have like a 6-inch or a 8-inch scope, go to actually low power should bring it in.
Okay.
Initially, you just see like a little fuzzy thing, and if the scene's good, then up the power on it. See if you can actually see the dust lane running through the center of the galaxy.
Nice. And just to show you that image again, so yeah. Nice.
It was actually a guy by the name of Stephen James O'Meara. He's written probably about 5 books on deep sky objects.
Oh, wow.
And he came up with the Outer Limits galaxy.
Now, I see it's also called the Silver Sliver Galaxy.
Yeah, that's another nickname. I kind of like the Outer Limits one because it's such a good show.
Of course.
I could see why O'Meara actually liked that or used that name.
Yes.
Because it was on the very first one, I think, was the Galaxy Beam. The very first Outer Limits it ever showed. And it was, the thing about Outer Limits is it usually probably caused more nightmares among children.
We don't have to talk about that now.
Outer, Rod Sterling's The Twilight Zone had nothing on the Outer Limits, although there were some good Twilight Zone ones also. Back in the old days.
Well, I wanted to recap because I know we're at the top of the hour. Let me recap real quick. If I turn off the lines, can you find me the great, not you, Kent, but everyone else, can you find me the great square of, if I turn off the lines, here, let me shake it up. There we go. Can you find Cassiopeia? Can you do that real quick? And Cassiopeia is over here. Can you find me the great square of Pegasus? Oh, where was that? Great square. If we got Cassiopeia, we're going to slide over. Do you see the 4 great big... It won't be a perfect square, but it's close enough. Okay, now if we go and we try to make that triangle here, this is where we're going to find that blue Snowball Nebula, the one I mislabeled. It's going to be right in this area. It's also going to be halfway between the beta star and the beta star here. So the beta star of Pegasus, the beta star of Cassiopeia. And it'll get you kind of in the right area. You've got the 3 curves there, and you can check out the Snowball. Andromeda. Well, you can actually see Andromeda right now on the program. If I zoom out a little bit, maybe it'll disappear. No, it's still there. Okay, so Andromeda real quick, if you don't remember where it is, we are looking for Cassiopeia, and the larger triangle is pointing to the gamma star in Andromeda. So we have 1, 2, 3. And then gamma goes 1, 2, 3, and the Andromeda is right on the edge there. And then, that's not gamma, is it? Gamma's this one. What did I say this one was? Beta.
It's beta.
Beta. Oh, you let me get away with that. Okay, this star, the beta star. All right, and then we're going to slide on over to gamma, and then we are going to look in this region and find, let's see, we're going to go partway until we see that cluster. So here's the gamma star. This is M34, and then
right in Perseus.
In Perseus, and halfway in between is going to be the Outer Limits. So yay, we did it! Woohoo! What does that mean? That means that means we're saying hi to Brian. That means that now you can go outside and take a look and see how many of these that you can find. The more you practice, the better you're going to get at this. Kent didn't just get good at this all of a sudden. He did one little constellation, one little piece at a time, and each night he would go out, do it again. Each night, go out and do it again. And this repetition is going to build those star patterns into your brain. It'll become so much easier, especially if you just go after one new thing a week. At the end of 50 weeks of the year, 52 weeks, you'll have an amazing, amazing knowledge of the night sky. So a couple of questions came in about more resources. Look at the back of our handout here. The handout is linked to the very top of the chat. You'll find equipment recommendations. Also, Sky and Telescope or Astronomy Magazine is great. And if you have specific questions, you can always send us an email to questions@centralcoastastronomy.org. Right now, before we actually take off, because I have one or two more announcements, if you could drop a note of thanks to Kent and to Brian and to all the astronomers that helped out with tonight's presentation, that would really that'd be really awesome, because we're all volunteers. We're just volunteering our time just because we're so passionate about the night sky. We want you to get out there and go look. That's really what we want for you, because it's just amazing. And so if you also have some friends or you family members, you can bring them out and show them and share what you learned. It'll help cement what you've actually taken in tonight, as well as being able to teach it to others. Just makes that world a better place by instilling that curiosity in them as well. All right, so normally we would have telescope viewing. I know we had a few of those questions. We got clouded out, so unfortunately for Brian, I know he's like, oh.
Yes.
So
next time,
which reminds me, the next time we are planning is, do we have that date, Brian?
Yes, February 19th.
Okay, so write that down, because it's not posted anywhere yet. So February 19th, we are planning to do another live. It's just going to be the telescope views. And
right.
So it's not going to be as in-depth that we went into with Kent. It's just going to be looking through the telescope. And which reminds me, if you have requests, let us know, because we would love to be able to share that with you as well. Okay, any last questions there, Brian, that came through that you wanted to answer, or announcements, or...
No, I think we're good. I guess, of course, this is at the end of the presentation, but keep in mind that we have almost 2 years worth of these presentations ready to go on our channel. Be sure to like this video and subscribe to our YouTube channel. And what we recommend is watch the video once when you're inside and warm. And then when you go outside, then you can listen to the description without having a screen ruining your night vision. Remember that when you're out in the dark, you don't want any kind of screen to ruin how sensitive your eyes will be. So then you can just listen, and you'll already be familiar with what we're all describing, so you can go out and learn more about the night sky.
Yes, and actually that idea came from a number of people who told us that's how they put us in like their pocket and have earbuds and listen as they're doing it, and we're talking them through the night sky, and because they've already been through it once. And so it was a great idea. So we were passing it on to you as well. The other question was binoculars. 7x50s are the little ones, and these are 25 by 100 millimeter. And I think that does it for questions. So thank you guys so much for joining us. It's so wonderful to be able to be back with you. Kent, thank you again for sharing your expertise with us and for spending tonight with us. Thank you.
Well, you're very welcome.
All right, and thank you to Brian as well for running the back end of things. Thank you to the astronomers who helped out as well at answering. And we will see you all at the next, we'll see you all on the 19th of January. Wait, no, what's next month? February. The 19th of February. And we'll see you all on the 19th, or maybe at another date as well. So thank you all, and we'll see you soon. Bye-bye.